Hi, in this video we will use the TI-84 Plus calculator to find the line of regression and then use the line of regression to make an estimate. First of all, we have to establish that there's a linear relationship between x and y. For this example, x represents the number of visits to an instructor's office hours. Y is the total points earned in the class. We've already established in a separate video that there is a linear relationship. So now we need to find the line of regression, and we have to make an estimate when x is equal to 25 visits. The line of regression is the line that's closest to every single plotted point. And we have a graphical representation of it here on the scatter plot. But we want to actually compute the formula for the line of regression. The structure is y prime equal to a plus bx. To calculate the line of regression, we have to enter the data. And I've already done this. So you press Stats, Edit, and you enter your data. As I mentioned, this has been done. Then we click on Stat, Calculate, and we select option 8. Once again, select Calculate. We have the two key regression coefficients. A is the intercept. That's 619.827. So remember, the line of regression is y prime equal to the intercept A plus slope b times x. B is 14.22. Another key metric is r squared, which is 0.933. We'll come back to this metric. First, we'll focus on the regression coefficients. So we take A and B and we plug it back into the original equation. Thus, the line of regression is y prime equal to 619.827 plus 14.22x. We can use the line of regression to make a prediction. So if a student has 25 visits to their instructor's office hours, what would be the expected total amount of points that they would earn in the class? Well, we go back to this equation, we replace the x with 25, perform the computations, and I went ahead and rounded it to a whole number. It turns out that based off our historical data, we would expect around a total number of points of 975 out of 1,000. Now, to demonstrate the accuracy of the line of regression, there's a few metrics we may want to represent with the line of regression. One of them is called the coefficient of determination. That's r squared. I had mentioned it earlier that it's computed for us by the TI calculator. It's 0.93 or 93%. That means that 93% of the changes in y are caused by the changes in x. We always want r squared to be close to 100%. So this is a very high r squared, which is great. We also sometimes calculate what's called the coefficient of non-determination. 1 minus r squared, 1 minus 0.93 is 0.07, which is 7%. We always want this value to be a very low number. Thus, it looks like we have a strong line of regression that we can use to help us better understand the data set. Thanks for watching the video.